This is the video for homework for Chapter 3.2 written homework questions. The first question is problem number 16, which we're looking at right here. First, what we have to do is match up, given these values here, match it up to the histogram. So let's zoom in a little bit there, get that a little bit more. And so looking at this here, you'll see the different shapes of the histograms. They're all pretty symmetric, maybe a little bit skewed here, and so that would give us some indication of the values. But again, this section on standard deviation, which is spread, how spread out they are. And so key thing is 32 to 82. There's a big spread there, big spread from 23 to 123 versus a smaller spread here with 48 and 56. The spread, it's not this spread out as much, so that's going to have the smallest standard deviation. So to me, that would then be the first thing we're looking at there, where you see, excuse me, that B matches up with, B is matching up with 1 because of that spread. And also the mean is in the middle, 53, it's symmetric, so we have that first one there. The next one that we could look at is which one has the most spread, and this is standard deviation is 22. So the one that has the most spread would be, we look at the graph that has the most spread, and then that becomes C over here, because it goes from 23 to 123, has the largest standard deviation, since that's what standard deviation measures. Also notice the mean is 53, median again, because we have this symmetry of that graph there. And it looks like the mean and median somewhere here around 53. The tougher ones are the next two, and graph 3, or the information on 3 matches up with graph A. And notice they have very similar standard deviations here. The difference is the mean. So I'm just looking to see where the middle is. You can see in each of these there's a kind of a different value here. Here the middle's around 53. And here the middle's around 60, and so that's how you would match them up with those there. So that's the answer for number 16. Number 17, we have some data on 2 different types of classrooms. What we have here is the scores for the exam scores, like it says there, exam scores. And so which course has more dispersion? And again, that word dispersion, as we look at that word dispersion here, this is another word for spread. So be mindful, that's another word for spread in terms of dispersion. That's what we're talking about, standard deviation, range, those types of terms. Which one has more dispersion within them? So what you would do if you graph those, you could take a look at the dispersion. You could also then calculate it other ways. So for example, this one said use range. So in this first one, using range as the calculation, you can then see we have these values right here. You'll see one has 29 and one has 28. Pretty close, but the traditional classroom has more spread using the range. Now if you're going to use standard deviation as a measure, which we're not going to do by hand, even though over here, this is the hand calculations. You'll get, using StatCrunch, 8.837 for one of them. So that's a measure for standard deviation using StatCrunch there. And so comparing the traditional with the flipped, what we end up with is, again, this is for traditional using StatCrunch. This is by hand. And then what's not noted here for B is if we used, not the traditional, but for the flip model, the standard deviation is equal to, your S is going to be equal to 7.85 in terms of if you did the standard deviation for the flip model. And then question C, which is not here, I'll articulate the answer of question C. Suppose the score 59.8 right here that turns out to be 598. What would, how does this affect the range of standard deviation? Which properties is this illustrating again? So if this turned out to be 598 right here, instead, that would affect the range because you subtract the min from the max, and then also the standard deviation would be influenced also, since the standard deviation uses the mean, and the mean is affected by outliers, that the standard deviation would also be affected there. And so what we're talking about in this area is that neither the range nor the they're not resistant. And so that's the property that we're thinking about. Okay, that's number 17. Let's go ahead and look at the next question here. We had a couple of questions here, 29 and 33. These are important ideas. Here's question 20 on the empirical rule. And so make sure you're referring to your notes here when we're looking at that empirical rule. And what's happening here is, what we're looking at here is the question, what percentage of people has an IQ between 70 and 130? And so what's going on in this case here, the answer is going to be 95%. And again, that's related to, going over here and make some space here. Again, what you end up having to represent here is what we want to do is you want to make a imagine here all the people, their IQ scores. It's going to be normally distributed. So it's going to look like that. In the center, the mean would be 100, and then one standard deviation. The standard deviation is 15, so you have 1, 2. So here's your 130, and then 2 standard deviations behind. There is your 70, because going up by 15, that's a 30. This is 115. This is 85. And then from our notes, what we learned from our notes, from class, was that within 2 standard deviations, right, within these 2 standard deviations, this is 95% of the population falls within 2 standard deviations. That's from the empirical rule. What percentage of people has an IQ score less than 70 or greater than 130? So if you think about that, if 95% fall within here, and then here has to be 2.5%, and on the other side we have 2.5% approximately. And so what we're looking at is a 5% total there, like it says over here. And then what percent has an IQ greater than 130? That would be on this side over here. What we're looking at right here, this is greater than 130. So that's the answer for 129. And then number 33, looking at that, suppose the Professor Alpha and Professor Omega each teach biology. And then what we're trying to decide is which professor to take from what professor to take. Records obtained from past indicate that students in Professor Alpha's class have a mean of 80% with a standard deviation of 5. And then the other class, 80% standard deviation 10. So in this case, the standard deviation, because it's smaller in this one here, means that the students kind of are closer to the average, where 10% is bigger, which means you'll have students score 60 and 70 and 80 and 90. And so this 5% is what indicates that it's going to be more people are closer to the mean. And so again, that's what's kind of explaining the answer there. But again, I'm using that standard deviation to make that distinction there. And actually, before we finish this up, I would kind of, as what's reading there, what they're talking about is the empirical rule. And that, again, if you look at the normal distribution of a grade, the averages are 80. The averages are 80 here. And so you'll know based on the standard deviations, again, what they're calculating is if someone is 2 standard deviations, 90 and 70, that's 95% of that first population is going to be within 70 and 90. So 95% of the students approximately pass Professor Alpha's class compared to Omega's class, which has a bigger standard deviation. And so that's how you would make your decision.